Okay, I'm going to assume that you clicked on the link to this file over here. That is, you clicked on this video over here. If not, you're just getting to this by the YouTube. But let me just read this to you. It says, there is a Chinese curse that says, may you live in interesting times. Like it or not, we live in interesting times, and we really do. These are indeed times of danger and uncertainty, but these are also times granting the least of us opportunities. Here's one such opportunity. Many instructors share their content, not only with their students, but with the world via the internet. Here's an example, and I will go through that with you. This is a clickable link. You can click on that, and you'll get to the exam I got over here. Not only does this guy post his exam, which I do as well for a lot of my courses, but I also post video solutions, and so does he. All right, you can look at those. Now, what I did, and what you may want to try to do, is create your own video solution to the problem. All right, you could do that, and certainly you could share that with the web. And YouTube's a great place to share it on. So I would say, take the exam. You want to record it and post it, that's great. By the way, my version of the exam, all right, that's what I'm going to do on the internet, so I'll do today. I refer to a computational aid. I do, I mention it. All right, I mentioned I'm used it to do some computations. Although we don't use computation on exams at Essex County College, you should start to learn a computer algebra system, and you really should. All right, so let me go to the document and say I'm done with this one. I'm going to click on that this guy's exam over here. I'm going to start to work his exam as if I were a student in his classroom. All right, now this guy is a teacher. He's a teacher in California, also in a community college system. He's quite talented. What do you mean that he has videos that are popular on YouTube? All right, anyway, over here, what does it say? It says, let y equal, and it gives me a function. It says compute dy. Well, I'm gonna write down dy dx. Whoops, sorry about that. I'm gonna write down dy dx, and I'm differentiating this guy over here. And what's that gonna be? Well, I'm using a chain rule. It's gonna be 5, and then 1 plus x cubed. I'm gonna reduce the power by 1, that's 4. The chain rule, go to the inside, what do you get over there? 3x squared, all right? So I got the derivative down. Remember, on a multiple exam, you're not given credit for anything except choosing the correct answer. Then he says over here, you're going to have to get the dy. So let's write the dy down. What's dy going to be? It's going to be 5. 1, this is called the differential, by the way, to the 4th power, 3x squared dx. And he wants to know what dy is when the x is 2. Let's write this down. Well, 2 cubed is 8. That's to the 4th power. And then you get 3. X squared is 4, because 2 squared is 4. And what's the dx? It's given to me as 0.0005. Again, if you took a calculator out and did that, I'm going to just say I did it, and I'll talk about using a computational device, which I'll post a video for that, all right? And I will post a video, and that'll be linked to that sheet we just covered, all right? And what I get 196.83, approximately. Again, there's more digits over here. But I look at this thing, and it's not this one, it's not this one, it's not this one, it's not this one, so it has to be none of the above. All right, let's go to the next question. The next question says differentiate. And I'm looking at it's I'll write this down, differentiate. So I'll write f prime. And natural log of sine x, so it's going to be 1 over the sine x. It's 1 over. Now, the derivative of sine is just cosine, so I'll put this over here. So what I do, I just differentiated that term there. Let's go to the next term. And that's going to be minus its derivative, 1 over cosine. And now the derivative of cosine sine, so I get plus sine now. I don't see that answer listed, so I'm going to just massage it a little bit. Common denominator would be sine x, cosine x, and then let's see, you get cosine squared plus sine squared. Well, now I immediately notice that I got a Pythagorean identity, and what's going to be 1 over sine x cosine x. Now, I don't see that in the answer either, so I'm just going to rewrite this. 1 over sine is cosecant, and 1 over cosine is secant. Now, I'm looking at the key. I'm looking for that answer, and do I see that? And I do. It's letter A, cosecant, secant. Let's go to the next one. The next one says, Pikachu is trying to use Newton's method to find a root of this problem over here. Well, let me write this down, and Newton's method is all about finding roots. What's f of x? It's x5 minus 5x plus 3. I got to get f prime, I'm going to use Newton's method. And again, I'll keep reading, but I know we said Newton's method. That's going to be 5x to the 4 minus 5. That's not so bad. And it goes on to say, which of the following is a bad initial approximation? Well, let me write down what Newton's method is. I'm going to write down xn plus 1 would equal xn minus f of xn over f prime of xn. And he's saying, what would be a bad choice over here? Well, a bad choice, looking at it, would be where I couldn't do the computation. And there's only one circumstance I could do the computation is when f prime is equal to 0. So I want to write that down for you. So f prime is equal to 0. Well, I'm going to write this down. It's going to be 5. I'm going to factor out the 5. It's going to be x4 minus 1. And again, I'm looking at it. It looks rather simple to do, but anyway, you could factor that x squared minus 1, x squared plus 1. And we're just dealing with real numbers. 5, x plus 1, x minus 1. Whoops, that doesn't look right. Get my eraser out. Got excited there. So let's see, 5, x plus 1, x minus 1, x squared plus 1. And when would this thing become 0? When x is equal to 1 or minus 1. Well, let's look at it. It's not this one. Oh, look at that right there. Are there any other choices there that would be bad? No, there's no other choice there that would be bad. Thank you. Let's go to the next question. This one is about taking a derivative of an inverse tangent function. All right, now you should know the derivative. I'll write this on the side for you. If I have, f of u is equal to arctangent of u, you should know the derivative of this thing, f prime, would be 1 over 1 plus u squared. All right, you should know that. Let me erase that. I don't really need to write that down, but you should know that derivative. So what I'm going to do over here, take the derivative. So what is it going to be? Let's see. Let's write this down. This guy's going to be equal to, let's see, 1 plus the argument squared. Well, that argument squared is going to be e to the x minus 1, because when you square the square root, it just disappears. Now times, I got to use the chain rule, and I got to go to the inside now, and that's a root problem. What's that going to be? 1 over 2 times the root of e to the x minus 1. And then I got to go to the inside of that, which is e to the x minus 1, and take its derivative, which is just e to the x. All right? I'm looking at that. I don't see the answer listed, so I need to massage it a little bit more. And the first factor I'm getting is 1. And the bottom, this bottom here, looks pretty simple, by the way, because the 1 disappears. You just get e to the x. Then what do you get over here? You get 1, you get a 2, and you get this over here. And then you get e to the x over here. What happens here? This disappears, right? What do you get? You get 1 over 2 root of e to the x minus 1. I'm going to look in the key, by the way. And sometimes look in the key. What are you looking for? I'm looking for an answer that looks exactly like that. And if I don't see it, I'm going to say I made a mistake somewhere. And what do I see over here? Let me take a look. And do I notice it somewhere? I think so. I think it's right over here. I want to make sure of that, by the way. I'm going to say C. I'm seeing the 1. I'm seeing the 2. Yeah, looks great. All right, let's go to the next one. It says, which one of the following is true? Well, looking at it, I kind of know the first one is not true. And why is that? That would be 3x squared. So that one's not true. All right, let me do another one. And the other one I'm going to do is this one over here, number C. I'm looking at the easy ones first. And this one's not true either, because 3 to 3 is 27, and the derivative of 27 should be 0. Now, if I'm looking at D, by the way, B I'm going to talk about, but if I'm looking at D, I'm going to point out it really doesn't look that bad. And why is that? What am I really differentiating? I'm differentiating x to the minus 3. And what would that give me? Minus 3x to the minus 4, which is minus 3 over x to the 4. So this one is true, so I'd circle this one over here. But you know what? I still want to look at B. All right, I'll write this one down for you. So B I'm going to write down as 3 to the x power, and I'm going to write, natural log of y is going to be x times ln 3. Differentiate both sides implicitly, 1 over y. This is going to be y prime, and that's going to be equal to ln 3. That's pretty simple. And y prime would be y. Well, y is 3 to the x times the natural log of 3. And clearly this is false as well, right? Not true. What is its derivative? That's its derivative over there. So again, 5 is D. All right, let's go to number 6. Number 6 is an implicit differentiation problem, and I'll write this down for you. It's going to be x times the sine of y and then minus y times the sine of x equals the number 1. And I'm going to differentiate both sides. So I'm going to be differentiating the left side d dx and the right side d dx. Now someone says, which side are you going to do first? The right side looks really easy, it's just 0. Let's do the left side. And again, it's a product rule, so it's not that bad. So I'm going to say, let's see, it's x times the derivative of sine y, which is cosine y. Chain rule, the derivative of y is going to be y prime. Plus, derivative of x is 1. You could write down dx, but that's 1. And then sine y. All right? I'm kind of running out of room, so I'm going to do it. I want to point out this minus sign may cause trouble, and be very careful about this. So I'm going to write this down. I'm going to say, minus y times the derivative of sine, which is cosine of x. And then it's going to be minus, let's see, the derivative of y, which is y prime, times the sine of x. All right? And this is going to be the left-hand side. I'm looking at that, and it looks like it's all over the place. So what I'm going to do is I'm going to put the y primes together and the other things on the other side. So as I do that, I'm going to be factoring y prime out. And when you factor y prime out, and I want to point out the two terms I'm looking at, this term has y prime in it, and this term has y prime in it. And what would I be left off with? Let's see, you'd be left off with x times cosine of y, and then you'd be left off with sine of x. Equals, remember, so we take the other side. Well, what do I get? I get y cosine of x minus the sine of y. Well, I think I'm ready to write down y prime for you. What's y prime? Let's take a look. It's going to be y cosine of x minus sine of y. And then the bottom's going to be x cosine of y. Whoops. Minus the sine of x. Let me look in the key, see if I see that. I'm hoping I see it. If I don't, I have to rearrange it to make it look like it's in the key. And I'm looking at this one over here, and I'm going to look at A first. I get y cosine x minus sine y. I got the top right. X cosine y. Oh, look at that. It's letter A. Now, granted, I wouldn't look at the other ones at this point. You can move forward. All right, now I'm going to move forward to question number 7. Again, multiple exams, I kind of appreciate these things, but you could be hoodwinked into taking the wrong answer, by the way. This one over here wants to get y prime, and I don't like the 1 over secant, so I'm going to write it a little differently. It's really cosine. Let me put a line here. And I know the derivative of that thing is pretty easy. It's just simply minus sine of x. Do I see that in the list? I do, and it's letter C. Well, let's keep moving through it. And this is a typical exam length at this level of calculus. All right? So let's take a look at it. This one says, if f of x equals this thing, find the second derivative. Well, I'm going to start writing down one derivative at a time. The first derivative is going to be e to the x squared times chain rule 2x. I'm going to put the second derivative down. It's the product rule now, right? So what are you going to get? Well, the derivative of e to the x squared, which is e to the x squared times 2x, and then I have the second function 2x, plus e to the x squared times the derivative of the second function, which is just 2. Again, if it was for me, I'd kind of simplify, because I don't see that thing anywhere in the K. This is 4x squared, e to the x squared, plus 2 e to the x squared. Now, by the way, if this were me taking an exam, I would also factor a 2 out, and I'd factor e to the x squared out. And we left off there. You get 2 x squared plus 1. Let's see if I did that right. 2, 4, x squared. Yeah, it looks all right. Yeah, I think I did okay. Look at the key, though. I don't see that answer in the key. What answer I see in the key, though? I see this in the key. And where is that? Let's take a look at that again. That's going to be letter, what letter are we on? We're on question 8. Oh, letter A. Let me just make sure I said that. 4x squared e to the x squared plus 2. And you notice I'm careful of looking at it. Yeah, I'm going to agree with that. All right, the linearization. And linearization is basically just the equation of a tangent line at the given point. So the first thing was write the point down. The point is where x equals pi. And then I got to figure out what the f is at pi. Put this over on the side. F of pi is just the sine of 2 pi. A relatively simple number at 0. The next thing I do is got to get the derivative for the slope. and that's going to be, let's see, 2 cosine of 2x. And the slope of this line is going to be f prime at pi. What's it going to be? 2 times cosine of 2 pi, which is another really nice easy number. Cosine of 2 pi is just 1, so we get 2. So m is 2. So what do you get? Well, I'm going to use the y minus y1 equals m, x minus x1, and you get y minus y1. Well, what's y1? I'm looking at it, it's 0, equals, what's m? M is 2, x minus x1, and by the way, this is the point x1, y1. What do you get over there? X minus, pi, look at that. So someone says, what's the equation? It's y equals 2x minus 2 pi. Now, in most calculus books, they don't call it y, they call it a linearization function, which is y is a function of x. That's a linearization, and it's 2x minus 2 pi. All right, let's look at the k and see if we see that anywhere. And I'm kind of looking around, because I'm dizzy looking at keys, but I'm seeing it, and it looks like it's letter C, but I do want to make sure of that. And I'm seeing 2x minus 2 pi. Yeah, we're done. Go to the next one, and the next one's a second derivative problem, all right? And I'm going to put a little line over here, and again, I'm kind of, moving around. I know things are bleeding into other things. I've got to start being careful, though, because the next questions are really, they want to see my work. All right, they want to see it. And here they don't want to see my work, just want the answer. Do I know the derivative of the r cosine? I do. And what's it going to be? Let's write this down. F of x is equal to r cosine of x. I certainly know the first derivative for that. And what's that going to be? Well, it's minus 1 over the root of 1 minus its argument squared. That's going to be x squared now, all right? I'm going to write it a little differently because I don't like the way that's written. And that's going to be minus 1 minus x squared to the minus 1/2. And I'm going to take its derivative now because I want to get the second derivative. And that's what they're asking for. All right, what do you get over there? Well, you get 1/2, 1 minus x squared to the minus 3/2, because I'm taking 1 from that. Chain rule, I get minus 2x. All right, I'm going to clean it up a little bit. I know the 2's disappear. I do get a minus sign, so say minus x. You may wonder what I just did there. I just did this and that. And then what do I see in the on this thing? I see it's on the bottom with negative exponent. I actually see the square root. Whoops, I need to do that. I actually see the square root of something being cubed. And that's going to be 1 minus x squared cubed. Now, if I don't see that in the key, I certainly could rewrite that. But anyway, let me go look through it and see what happens over here. Am I seeing it? Let me take a look at that. I'm looking for minus x. I do see that, and it's letter C. I want to be careful and look at it, though, and make sure it is letter C. Minus x, I see the root. Yeah, it's looking fine. All right, let's do number 11. Now, number 11, I really don't like the question because you have to make assumptions about using this to figure it out. And the assumption you need to make is, I'm going to say they want the derivative, the quotient rule, and I'm going to write this over here, f of x over g of x, and you're taking its derivative, all right? So d dx over here. And what's that going to be? Well, I'm going to write it down because this is not the answer to the question, but it's going to be, I have to take the square of the bottom, and then you bring the bottom to the top. I'm just writing down what the rule is, by the way. And then it's going to be f prime minus the top, which is f of x, that's an f, times the derivative of the bottom. All right, now someone says, what are the assumptions to make? Well, they want me to use logarithmic differentiation. And let me write this down for you. I'll write down y equals f of x over g of x. And the assumptions I have to make the assumption that both f and g are positive. That's an assumption I need to make. And why is that? I'm taking logs of it, all right? Now, someone says, could you make the assumption that they're both negative? You could. The only real problem you have, if you write that down, you'd have to say, f of x and g of x would both have to be less than 0. That's another assumption you can make, and that's going to work out. But I'll be honest with you, it's kind of hard to deal with that, all right? The reason for that is that if they are both negative, when you're taking a log of it, you'd be taking the logs of negative things. Let's not worry so much about that. Let's just go for the what he's asking to do, which is logarithmic differentiation. So I'm going to put down ln y equals ln f of x minus ln g of x. Now, there's one thing you really are assured of at this point is that both f and g are definitely not zero, all right? That's one thing you're assuming at this point. All right, so let's put this down, and I'm going to write down the derivative now, the derivative of both sides. And how do I do that? I just start taking its derivative, all right? I'm not going to write it down, but I'm taking the derivative of both sides. So what's the derivative of the left side? It's 1 over y times y prime. Now, what's the derivative of the natural log of f of x? It's going to be 1 over f of x times the derivative of f of x, which I'm going to say is f prime, minus, let's write this down, 1 over g of x, right? I'm sorry, you know what? I made a mistake, and I have to correct it too. I just noticed it. Let me get my eraser out. I don't know why. If I said that, I'm sorry. It's the natural log. All right, sorry about that. And what I'm going to do over here, 1 over g of x, and then the derivative of g, which is called g prime. All right, so I got to write down y prime. And y prime is I multiply both sides by y. Well, what's y? And y is a quotient. It's just simply f of x over g of x times, again, let me point out what I'm saying over here. This is y. I'm multiplying both sides by y. What's y? It's written over here. I see that part, f of x over g of x. But I got troubles. I'm still not seeing what it's supposed to be, which is this thing up here. So I'm going to get this thing into one term by getting a common denominator, right? And what's common denominator going to be f of x times g of x. And what do you get then? You get f prime of x times g of x. You know what? I need more room. I'm going to erase this over here. I just noticed it. We extend this out. And then it's going to be minus g prime of x times f of x. All right, let me keep going here and see if I can figure this thing out. Well, this cancels off. And what do you get in the bottom? You actually get what you expect to get, which is g of x, whole thing squared. What do you get on top? F prime of x times g of x minus g prime of x times f of x. All right, let's look, see if that's what we got, what we're saying we're supposed to get. And looking back over here, I'm getting it. Someone says, oh, the order, the factors are all different. It doesn't matter. Multiplication is commutative. I got the exact same thing that we expected to get, by the way, all right? Again, some assumption being made and some, hand-waving about it, what if f and g were both negative, by the way, all right? Anyway, let's keep going. And for number 12, again, for number 12, I would say that number 12 could cause some problems if you don't have a calculator, because I'll be honest with you, I wouldn't want to have to do this by hand computation. But the first thing they're asking me to do is they're asking me to find a root of this equation over here. And it's so important you start to realize that really what they're asking to do is solve that for 0. So I'll write this one down. So it's going to be the natural log of x plus x would be equal to 0. And this is what I'm going to call my function. And Newton's method is all about finding finding zeros of functions. So I need to write a few things down, by the way. Certainly got f of x written down, but I need to write f prime down. And f prime would be 1 over x plus x. Then I got to write Newton's method down. And what's Newton's method going to be? I'll write it down for you. It's going to be x n plus 1 would equal xn minus f of x n divided by f prime of xn. Now granted, for me it's a calculator exercise, and I will go through that with you. I'll post a video, but I want to write down what you're doing first. The first thing you're doing is you're saying x1 is equal to, well, they told me it's 2. And then to get x2 down, what you're going to do, you got to use your calculator, and what are you writing down? x1 minus f of x1 divided by f prime of x1. And if you do this on a calculator, I don't want to go wild with it, but I'll write down what I got in a calculator. I got 0.2046. 6. And I'll show you on the calculator how to do that when I post the video. What's the next one going to be? X3. What's that going to be? X2 minus, you know what X2 is now, that approximate number there, f of X2 divided by f prime of X2. All right, again, I want to point out what f is. This is what f is over here. It's the natural log of x plus x. What's f prime? It's this guy over here. Newton's method, fairly straightforward. The computation, not straightforward. Use a calculator to do that. But I'm going to indicate that this over here, and if I use a computer to do that, or a calculator, I'm going to get a number. The number I approximately get is 0.4393. And what's interesting about this thing is that you can say, oh, they're changing. It's first 2, then it's 0.2, then it's 0.4. And the bottom line is you keep doing this over and over again, and at some point it's not going to change, right? And I'll also show you that on the, when I use the computer algebra system, I'll show you that this thing eventually boils down to a pretty simple number. And the number it boils down to is about 0. I'll put this over. It finally settles in on a number like that looks like this over here. All right, and again, I'll go through the computer algebra system later. All right, let me go to number 13. Number 13 is an implicit differentiation problem. And looking at it, it's going to differentiate both sides. I'll write that down for you. I'm going to differentiate the left side. That's x squared plus xy plus y4. And the right side, I'm going to differentiate that too, with respect to x, by the way, and that's going to be 10. So let's take a look at it. The first thing, you know, it's pretty easy. It's the first derivative is just 2x. Now you could say, oh, dx if you want, but we're not going to do that. Then we're going to put plus. I'm going to say, let's see, the derivative of x is 1 times y, and then it's going to be x times the derivative of y. I'm just going to say y prime. All right? Let's do the next one. What's the next one going to be? 4y cubed, chain rule, y prime is equal to, well, the derivative of 10 is just 0. So I'm going to put things together that really kind of belong together. Like this guy here really belongs with this guy over here. And let me write that down for you. And I'm going to factor out the y prime. And what he left off with? He left off with x plus 4y cubed. The other terms are going to subtract them from the left side, so and the right side. So it's going to be minus 2x minus y. And then I'm going to say y prime, which is really dy dx. You may wonder why I didn't write that down initially, because it's too much work. I mean, y prime is easier for me to write down. And what do you get over here? You get minus 2x minus y over x plus 4y cubed. I'm going to simplify this a tiny little bit, minus, and I'm going to put down 2x plus y, and on bottom I'm going to put down x plus 4y cubed. Put a box in that, and call it a day. And it's really not a bad thing to do, but again, people do make mistakes, and be aware of that. And you want, the more practice you do, the less likely it's going to make a mistake. Well, let me do the next one. And the next one, I'm going to write down what the function is that I need to differentiate. I'm going to write down f of x is equal to the natural log of 1 plus x cubed. I'm going to do the first derivative. And what's that going to be? Well, logs are pretty easy. It's going to be 1 plus x cubed, 1 over that. The derivative of x cubed is going to be 3x squared. All right? So I got that part covered. And then I'm going to go to the next thing, which is second derivative. And that's going to require a quotient rule. So it's going to be 1 plus x cubed squared, 1 plus x cubed times 6x, well, that's not so bad, minus 3x squared, and the derivative of the bottom is going to be 3x squared. All right? And I'm going to try to, get a final answer on this one over here in the neatest form I possibly can. And what do you see? You see 1 times 6x, which is 6x. All right, let me get my eraser out. It doesn't look right. So it's 6x minus 6x to the, I'm sorry, not minus, plus 6 to the 4th power. Let's say, yeah, I get that. Minus 9x to the 4th power. I'm still going to pull that together, by the way. And what do you get? Let's see, you get 6x minus 3x to the 4th power over 1 plus x cubed squared. Put a box in that. All right? So, again, it might look like it's a difficult question, but I mean, you might want to even look over that to make sure you're doing okay with that. And the problem with that is, sometimes you look over your work, you don't see things. I want to point out one common error. Again, I make it sometimes 2, 3 times 3. Some people say 6, right? They're really not thinking, by the way. But I understand that, by the way. It does happen, all right? Let's keep going. All right, this one is, you compute the dy. So let's write down this over here. So I'll put this y equals, I'm going to write down x to the minus 1/2. Then I'm going to write down dy dx is going to be minus 1/2 x to the minus 3/2. All right? So then the question becomes, what do they want? I don't think they wanted that. They really want the differential. So let's write this down. dy is going to be minus 1/2 x to the minus 3/2 dx. I don't think they wanted that either. What they want dy when x is equal to 9. Let me write this down for you. Well, it's going to be minus 1/2. And then you're going to get, 9, guess what x is, to the minus 3/2. And then the dx is going to be, what is the dx? Oh, it's 0.2. I can write it as 2/10, by the way. All right? Now, granted, if this were me on the exam, I don't think I would do much beyond that, but I'm going to have to do some arithmetic here because they want it to 3 decimal places. So dy, I notice the 2's disappear, right? So I'm just going to slash those things out. And 9 to the minus 3/2 is really the square root of 9, which is 3, and 3 cubed is 27. So it's really 1 over 27. I'll put this over here. That's not so bad. And then what do you get? 1/10. If this were me, I would leave it as minus 1 over 270. However, I do want to point out they want 3 decimal places. And again, hopefully I'll show you in a computer algebra system how to do that. I'm going to approximate it. And again, I'm using a computer algebra system. What am I doing? Computer algebra system could be your calculator, could be your cell phone. You could ask Siri, you could ask Google, whatever would be able to give it to you. And what is going to give you approximately minus 0.004. All right, I'll do that on calculator later. All right, let's go to number 16. We're getting close to the end of the exam, and let's write this down. They want the third derivative. You have to understand this is a derivative with respect to x. A, B, and C are parameters in the problem at this point. So what do you get over there? You get 2ax plus b. That's the first derivative. Let's do the second derivative. What do you get over there? You get 2a. Let's do the third derivative. What's the third derivative going to be? It's going to be 0. All right? So 2ax plus b, 2a, and then 0. We're done with that. Let's do number 17. As I do it, they want a derivative. I'm going to write this a little differently. I'm going to write it as 1 over x squared plus the root of x, I'm going to write x to the 1/2 over x squared. And since I'm taking a derivative, I want to write these things as powers. So it's x to the minus 2, and this is going to be x. 1/2 minus 2 is going to be minus 3/2. All right? What I'm going to do now, take the derivative. And what do you get there? Minus 2x minus 3/2 x minus 5/2. Again, I'm of the opinion this is a fine answer. However, most people are not in agreement with that. I'm going to rewrite it. You know what? I made a mistake already. I got to check out what I just said. That's minus 3. Sorry about that. That is not a correct answer. Now it's a correct answer. All right? Let's take a look at it. And someone says, what do you mean take a look at that? I'm going to try to rewrite that so it's in the form of the original problem. The form of the original problem had roots in it and positive powers. I'd certainly like to speak in that same tone. So f prime, it's just being polite, is minus 2 over x cubed minus, this is 3, 2, and by the way, minus 5/2 going to the bottom, it's 5/2, which is 2 and a half. So I can write this as x squared, and then a half power would be root x, all right? And again, if someone says, is that the good answer? It's not a bad answer. I mean, you could say, oh, this is the right answer, but I want to kind of rationalize that by multiplying top and bottom by root x. When I do that, I notice what I get in the bottom is I actually get 2x cubed. So what I want to do, I'm going to get my eraser out, and I'm going to do something to the first term. I'm going to multiply the top and the bottom of that by 2. What do you get there? Well, you get it, on the bottom you get 2x cubed, And on top, you get minus 4. Over here, you get minus 3 root x. And on bottom, what do you get? You get 2. Well, it's x squared times x, which is x cubed. What do you get over here? Well, you get 2x cubed, common denominator. On top, you get minus 4, minus 3 root x. All right? I don't like the way that looks, by the way. So I'm going to pull out a minus sign. I'm going to say 4 plus 3 root x and over 2x cubed. I would say this is probably the best looking answer. But again, I'm going to say all answers are the same to me. All right? All answers are the same. So if someone says, why would you go through that then? I just be polite. And why is that? Again, these were written like this over here. I probably should write the final answer in the same way. All right? But again, I like to pull the minus sign out, and that's fine. Let's go to 18. 18 looks like they want me to show something is true. And the way I'm looking at that, I'll write it down for you. So I'm going to write f of x down as the cosecant of x. And, someone say, how would you know it's true? I don't think I'd do limit definition on it, but you could. That's one way to do it. What I'm going to do over here is write this a little differently. I'm going to write it as 1 over sine. It's really the same thing. You could also write this as sine raised to the minus 1. And someone says, which one would you like to differentiate there? And I'll say I'd say this one looks pretty easy to differentiate. And I'll do that first. All right, so what's f prime? It's minus 1 times sine x to the minus 2 times, the inside's going to be cosine. All right, that doesn't look like what I wanted, so let's write this over here. It's going to be minus cosine of x, and sine squared is going to be on the bottom now. I'm going to say sine x. Is that what we wanted? It is, because minus cosine over sine is going to be minus cotangent. And then 1 over sine is just cosecant, right? Now, is that what we wanted? It is. Now, someone's going to say, oh, it's in different order. It's what we wanted. This is what we wanted. We got the cosecant x, and we got the cotangent x, so QED. All right, let's say you didn't want to do it that way. I'm going to do it another way. I'm going to erase this now. Again, don't think you have to do it 2 ways. I'm just going to say you could do it 2 ways. Let me erase this over here. And the other way I'm going to do it is differentiate the quotient. Now, let me go through that for you. So you get f prime of x, the quotient rule. I'm differentiating this guy now. It's the same thing, by the way. Sine squared. Take the sine to the top. Times root of 1, which is 0. Minus the top, which is 1. Times root of the bottom, which is cosine of x. What does this give you? Well, on top, it just gives you minus cosine of x. On bottom, you get sine squared, which is sine x times sine x. Well, looking at it again, what do I see? The same old, same old. The minus cosine over sine is minus cotangent. And 1 over sine is just cosecant. Am I getting what I expected to get? I am. I'm getting exactly what I expected to get. So another QED. All right, let's go to number 19. We're getting very close to being able to finish this problem set. Find the equation of line tangent 2. The first thing I would do is get the point. What's the point going to be? Well, they tell me x is 0. And then looking at it, what's f of 0? Well, it's going to be the root of, let's see, 1 plus 0 is just 1, right? Yeah, look at that. That's nice and easy. I also need to get the slope. So I need to get the derivative. What's that going to be? Let's write this down. 2, 1 plus x squared, and then a 2x. That's a chain rule. So I'll write down f prime at 0, and that's what m is. I'm plugging in. What do you get? Well, you get 0 over 2, right? What's that going to be? 0. Okay, let's write it down. I like the certain form of a line, and that form I like is y minus y1. This is called point slope form, by the way, x minus x1. Right, I know what the m is, and this is my x1, y1. Let's write down y minus y1 is 1, m is 0, and that's going to be x minus x1, which is 0. What does this lead to? Y equals 1, horizontal tangent line. All right, let's do the next one, number 20, our last question. And, I'll write it down. And what is it? Let's write that down. I'm going to say the function now is x to the x. So I'm going to say y equals x to the x. And so while you're doing that, I want to, use the logs to figure this thing out. ln is equal to x times ln x. All right? I'm going to differentiate both sides. And the different natural log of y is 1 over y times y prime, with the understanding that y prime is dy dx. Other side is going to be the product rule. So I'm going to say x times the derivative of natural log of x, which is 1 over x, minus the derivative of x, which is 1, times the natural log of x. Got to kind of clean this up. Y prime is going to be y times, well, x times 1 over x is 1, provided x isn't 0, by the way. Maybe I should state that. X can't be 0. All right? So let's keep going. One thing I should state over here is x should be greater than 0. So maybe I'll just say that when I'm doing this problem over here. Then when you go over here, minus, the natural log of x. All right? What's y? It's x to the x. So let's write this down. Y prime is equal x to the x times 1 minus the natural log of x. All right? By the way, y prime, again, I'll put it down now, is dy dx. And I'll put a box in this one over here. That's our derivative over there. And I think we're done with the exam. And again, this is, I don't think it was an unusually difficult exam. But again, you may look at these things and say, I didn't know that, I didn't know that. And that's part of looking at things, is to realize that the more you look at things, the more likely it is, you know what, I made a mistake. And I just noticed it. And I want to correct it. The mistake I made, the product rule. And again, I can always say I'm daydreaming. I was daydreaming, by the way, believe it or not. These are plus signs. Sorry about that. Okay? And I'm glad I paused for a moment to think about what I wrote down. And I was looking at it when I was speaking. And I said, where's that minus sign coming from? And then I realized the product rule, I don't know why I did that, but I get maybe daydreaming or whatever, not thinking. And that happens. But what happens on your exams too, you're going to lose points that way, all right? But anyway, I'm going to say I did okay in the exam, and mistakes happen. It's nice to have a key. And I also want to recommend that you look at the videos I posted. This video, of course, I recommend you look at. But also look at his videos. He does a lot of videos, and he does a lot of material that we're not doing, by the way. But I think, for the most part, this exam is very similar to what we're doing at Essex. Very similar, right? Not much different. The only difference on his exams, by the way, is he is using a calculator, all right? I don't use calculators on the exam at Essex, and you should be aware of that, for good reasons, by the way. Each of these questions could easily be answered on a modern-day calculator without understanding anything about the problem, by the way. Thank you.